Hi, I'm Deanna with Dakota Steam Learning, and I'm going to take you through our science experiment lessons, just so you understand the steps in it. I will be honest, ours is very, very similar to the scientific method. The difference is we are a STEAM perspective. That is what we are really focused on. And so we're focused on building students' critical thinking, creativity, communication and collaboration skills in as many lessons as possible, right? So we have all of our lessons designed in a way to have built-in communication and critical thinking, especially with science experiments. Not a lot of creativity because we need to follow the scientific process, and not a lot of collaboration necessarily. They will collaborate sometimes in the actual experiment, but we're really focused on creating this in a way that we still hit critical thinking hard and we still hit communication skills hard. So if you are wondering, we do have science activities and we do have science experiments. So, our science activities are a guided activity that allows students to experience a scientific principle. So, they are super guided and they tell them exactly what they need to do. They still have communication and critical thinking happening in them, but they aren't an experiment. So, they do not follow the scientific method at all. Or, I mean, they don't. But our science experiments do, of course. And we always have control variables and we have independent and dependent variables. So we are STEAM teachers, but obviously these are science activities and they're done in a STEAM way. But we always want to honor the difference between an activity and an experiment. So I want to make sure that that was clear before you are like, this isn't what I wanted. So let's go to what it looks like when you are going through an experiment with us. So we always tell students that they're going to be seeing a scientific phenomena, they're going to make a hypothesis, and they're going to draw conclusions after they test their predictions. So the first thing that we always do is we inspire them, and that's where we show them that scientific phenomena. We include a video or a picture illustrating the phenomena. Sometimes we link also and tell you a video that we recommend. That's also sometimes on there because sometimes we don't have access to lab equipment that other people do. So sometimes that's linked. Then we move on to the question section of this, and that's where we identify a question that needs to be answered based on the scientific phenomena. So the key question is revealed to students, and it's emphasized that this is a question that we're going to be answering with our experiment. So students then go ahead and write down the question. We always provide a version of our STEAM journal that has this empty so students can write it down, and a version where it's already documented for students because you get to decide how you want students to interact with the STEAM journal. Then we go to step number 3, which is research. We gather information that could help make predictions and identify procedures. So we start by activating schema. If you've ever done a Dakota STEAM lesson before, we always activate schema because this is what we're talking about in the differences. We hit hard on critical thinking. And so we pose questions about relevant information that are posed with the intent of initiating discussion because we also want them to critically think and communicate. So then we the intent is then you would lead students with a discussion, pairs, small group, whole group, however you wanted to do that, and we recommend using your typical discussion structure. Then after that, we go into the research. We review relevant information so that students are aware of it, and then we have them record inside of their STEAM journal. You'll notice we have a box where they can draw and lines so that you can differentiate based on student abilities and student needs at that time of the year. Then we go on to our step number 4, which is hypothesize. And that's where students are asked to identify what they expect to happen when testing the question. So we identify for them 2 possibilities for the hypothesis, and they make a choice. And during this, once again, we're asking them to critically think. It's also a great place to have a bit of a discussion. And on theirs, they actually do. We always have a third box in case they do not want to choose one of our hypotheses. Then we get into the experiment. So this is where students are going to gather data while we follow a procedure to test our hypothesis. So we review variable types. We then link them to our actual experiment of how, what are the control variables, what's the dependent variable, what's the independent variable in our actual experiment. And then this is where, once again, we hit really hard on critical thinking, because instead of just telling students what the procedure is, we review what a procedure is. Then we ask them to actually see if they can figure it out. So once again, critical thinking communication, this is a great one to have them do together and talk about. But you have them really think critically about how could you, using the information you already have, how could we structure our procedure? And so in their STEAM journal, they have a spot where they can, basically, they're hypothesizing the procedure, right? And then we go into the experiment, and this is a great place for self reflection, because they get to decide if their procedure is the procedure. A lot of times it's not. A lot of times they make little issues, and it's really good for reflecting for them. So then we have data collection that we will do during the experiment. So then we give detailed descriptions for each step of the experiment, and pictures are included when helpful, so that you can follow along. So this is the procedure that we intend for it. And sometimes it has sometimes it has like 3 steps, and sometimes it has 8. So it just really depends. Once you've gone through the whole experiment and you've documented data at every point that's necessary, then we move to step number 6, which is conclude, where we look back at our data and draw conclusions based on ours. So once again, we're going to hit hard on that critical thinking, and we're going to hit hard on that communication. And we ask students to draw conclusions based on our data. They have to reflect, was their hypothesis correct? Why or why not? And they have to do that in their STEAM journal as well. At the end, we always want to hit communication one more time. This is where they share their conclusions and prove their findings. So they explain the data that they collected, they explain their conclusions, and they justify how they came to them. And then they share and try and think of any next steps or like related questions that they could test. So then they can also do that. And this is where I recommend having them talk to 2 or 3 other people in class. You can do it jigsaw style, where they, have to meet with different partners. They could make this where you could integrate technology and have to make theirs into some sort of presentation. It really just depends on what your goals are during that part of the year. Remember, communication also at this point in um, the world is technology based too. So that's an important part too. So this is how ours goes. And I hope that kind of helps you if you're kind of wondering, why do I have all these extra steps inside of my science experiment? It's all with our goals for STEAM, enhancing critical thinking and communication and collaboration and creativity. At all times, that's at the forefront for Dakota STEAM Learning. And so we want to make sure that that all of our processes emphasize those skills. All right, I hope that you enjoy experimenting.